Hello, my name is Dmitriy, and I'm working as a software engineer in Norigin Media. So a bit of a background, our company is based in Oslo. It's a relatively small company, and two main things we are doing is we are doing video transcoding for content providers, so TV operators, broadcasters, and the second main thing is that we are doing TV apps for them as well. So that's what I'm going to talk about today. It's a quite niche industry. I don't think many companies are doing that, but I hope it will be interesting. So we are doing TV applications for many. So we have a lot of challenges, and first of them is we need to support a lot of platforms, because TV streaming applications should be available everywhere, not only in the browsers and native mobile devices, but also on a lot of different smart TV platforms like Tizen from Samsung or LG WebOS, or even some custom set-top boxes, for example, that could run on Linux, or some very custom Android TV systems. So back in the days, maybe 5-7 years ago, the main question for us was which technology to choose to cover all these platforms. And we had a lot of fights between should we go cross-platform or should we do native apps for each platform. We even had some kind of challenges that the web team writes their application, like TV app prototype, in one day, and native guys do the same, and then we give it to the management and they kind of compare, and the idea was that they shouldn't guess which app is native one, which is the web one. So what are of course the benefits for us for using the native apps were that you have direct access to all the device APIs, you have the best performance possible. Of course, you have multiple teams, multiple code bases. It was very hard to manage. You had isolated knowledge base because every platform knowledge is quite specific. And it was very hard to synchronize all the work between all these teams, because if you build in one project, it's much more common in this project between different platforms than different. So it's every single team needs to redo the same amount of work, re-implement the same UI, business logic, and it was hard to synchronize this. The next thing we kind of tried after native apps is something that's called hybrid apps, which is basically it's a native application that's running web view inside. So we can write our business logic and interface in JavaScript to build a browser application, and then it will be executed inside the web view on the mobile device, for example, or any native device. And why I put player as a separate thing here is, I will cover this a bit later, but in this industry we have to use native players. You cannot just run, just create a video tag and run DRM encrypted video on the web view, for example. But I will cover this a bit more later. And the benefits were, of course, we can have shared business logic and UI. We still have access to device APIs because we can communicate with the native layer of the application. But we still were dependent on the native teams because we need to support this native shell of the application. So it still were a lot of overhead in communication and how to deliver features, how to set this up properly. And of course you have web rendering performance, because your app is basically a web application running in the browser. So if you want to make it feel native, it needs to have native rendering, especially when it's coming to animations, for example. And yeah, as I mentioned, it was hard to manage the JavaScript to native communication in this case. Then we started to use React for, we started with the browser-based platforms. So first of all, the main browsers, and also Samsung Tizen and LG WebOS. It's also browser-based smart TV platforms. So you write your application as a browser application, and then it runs on the TV. So we started to use React, where you write basically HTML tags. Then, of course, we wanted to cover native platforms. So then React Native popped up, and we started to use that for Android, Apple, and more recently, it also runs on Android TV and Apple TV. And the difference is it's the same React logic, it's basically the same thing, but instead of HTML components, you write more abstract components such as view or text or scroll view button, just more platform agnostic. And then we went one step further to combine all of them. And now we're using React Native Web, which is basically, it's a web implementation of React Native widgets. So you write your code in React Native, and then you can use it in the browser platforms as well. So this is the first time where we can cover all the platforms with one single code base and still having native rendering view performance on native devices. So that's how we do the UI part. Another big problem in this industry is the video playback, because when I joined this company, I had no idea how complicated it is. I thought it just like create video element, put the URL of your stream, play, it plays. No, it wasn't like that. First of all, you have a lot of different streaming formats. So it's not as simple as just like MP4 file that you just play. It's a streaming format, which means when you request this kind of stream, you just get a manifest file telling you the list of small pieces of this video and how to download them. So when you're watching the stream, you actually download small pieces of the video every like 2 seconds, for example, and it's your browser or your device is constantly doing this. And for example, Apple has HLS format, Google is going for Dash, Microsoft was doing Smooth Stream. So there are a lot of standards that needs to be covered, and many browsers do not support all of them. And for our customers, we sometimes you never know which format is available from your customer. They can ask, okay, we want to have Dash streams on the Apple device, for example, where it's not as usual, for example. So we need to cover all these possible cases of streaming formats. Another thing, and this is the main reason why we have to interface with the native players and not like a web-based players on the native devices, is because you have DRM, which is digital rights management, and it's the encryption for the video streams. So when you have the link to the video stream, you cannot just take this link, put it into a player and start playing this, because this stream will be encrypted and you need to get some kind of license from the license server in order to decode this video. So this is the way how content providers protect their streams from being just shared with the friends, or that basically control the consumption of the videos. And third problem is that every single player on every platform has different interfaces, different player states, methods, like everything is different. So if we want to write a shared code base, we don't want to deal with this in runtime. We don't want to have in our code like conditions like is iOS do something like this, is Android do this. So how we solve it is we created our own something that we call Player Manager, which is basically the unified interface for all players we support. So we have that's the typical example of the difference of different players. Like for example, if you want to start to play a video from certain position, like let's say you finished watching some movie yesterday in the middle and you want to start it from this position. From the project perspective, we just want to call play with the URL and start position. But some players might support this method, but in some players there is no method that supports start position out of the box. So we had to do some additional logic. If there is start position, we seek to that position first, and then we start playing this URL. So this is how we handle this multiple players, is through this plugin or adapter way that we handle all the platform-specific logic in these adapters and plugins. And another example that was quite funny is that not every player supports pause method. In some players, you actually need to set speed to 0. From the project perspective, so this is the only part of the code where you need to do any platform-specific logic for players, is just to figure out which adapter or plugin to import. So we just check in if it's a web platform, we import Shaka adapter, which is the Google player from Google. And for native platforms, we import adapter for React Native, which is it's not an open source, it's an in-house one, but there are open source solutions for React Native video as well. Another quite complicated thing with the player is the player state. It's there are a lot of things that needs to be kept in the state, like the playback state itself, streaming URL, duration, position, like a lot of stuff. And again, every single player does this in a different way, so there is no normalized way of how they store this data. So in order to manage this complicated state in a very cross-platform way, we decided to use Redux just for the state management of this component. So in this case, it's a standalone usage of Redux, so it has nothing to do with React specifically or something like that. So Redux can be used for other cases. And in this case, we're using Redux to handle the state of the player. And that's like a very basic example of how it might look, is that we have normalized state that we think makes sense across all the platforms, all the players from all the platforms. So we have some kind of initial state where we have no stream, the player is closed, we have no duration whatsoever, and from the application we just dispatch an action. For example, like we dispatch play action, it goes to reducer, it changes the state to plain. And that's how we handle the state with the Redux. In general, when we see a problem that is common to all the platforms, we're just trying to extract it in a separate module, because then it's quite easier to handle this problem separately and also to update this small module. So that's how we created this kind of player manager. We do the same for the data layer, because all these TV streaming apps are quite similar in terms of how the content is provided. And our customers could have different backends. They can have different models for providing this kind of video assets and content. Some of them has REST APIs. Some of them are GraphQL. So we also created some kind of abstraction layer for this. When it comes to tracking and analytics, there are also a few different analytic systems that are usually used for tracking the video playback, like what are you watching, how you're watching it, what is the quality of the network, what is the bit rate, when did you press pause, when did you rewind to certain position in the video. This all gets tracked. And we created also some kind of unified interface that is able to detect all the events coming from all the players and automatically map it to this kind of analytic systems. And in terms of UI, as I mentioned, we're using React Native Web, and we started to use this component-based approach that I'll demonstrate a bit later. So we're using Storybook and React Native Web to build our UIs. So what is our UI toolkit? Basically, it's a library of UI components and certain shared UI solutions that are common across all the devices, but at the same time, they are quite specific to this industry. So they have components that we see across all these kind of streaming apps is, things like gallery items, menus, hero items, and things like that. So to show this a bit more, I will do some demo. So this is how this storybook looks like. So to the left, we have the list of UI components that we use as a building blocks to compose any kind of UI. These UI components are customizable because every customer wants different interface, but still they are quite similar in the sense of how they used. So for each component, we provide some kind of style customization options, which was inspired by Material UI framework, for example, for React as well, where you expose some kind of props or styles to customize. And in this storybook, it's a very good approach of building your UI components, especially if you reuse them across many projects, because you can isolate every component. Like for example, this one, you can render it in isolation from the application, so it's agnostic of where it is rendered. You can test it. You can also document it here, so there is no need to have a separate documentation portal for this. For this library. And we have basic components such as buttons, for example, category of gallery items, things like that. So it's a very nice way if you want to reuse your components in the future. And also, for example, this storybook is not specifically made for React. It can be used with Angular or Vue.js or React Native. So if in the future, for whatever reason, you want to migrate all your views into different technology, you can port all these components one by one without having to rewrite the whole code base. And in this UI toolkit, we also have some UI solutions. So it's not only UI components, but also solutions for example, in the browser platforms, there is a quite common issue is how to handle remote control navigation. Because when you press a key on remote, like up, left, down, right, the application needs to decide what to focus next. It doesn't know by default what to focus next. There is some standard that is kind of getting mature now to do this natively in the browser, but before there wasn't any. There was only this tab index, so if you are in the application and you just click in tab, it highlights different elements for accessibility. And for remote control, sometimes you have more advanced use cases, like for example, if you are in the side menu and you click right, it needs to jump to the first item in the row, and then it needs to scroll through them. So for example, if I'm in the second item and I click left, it goes to the first item, but if I click left again, it jumps to the menu. And the reason for having this solution is we don't want to, for every item on our screen, we don't want to specify what exactly should happen when you click left. This solution should be very smart and generic. So this is basically just a wrapper for any React component. So to make this component focusable or recognizable by this remote navigation system, it's as simple as that. Just wrap the component in this function, and it's automatically handled after this. So this library automatically calculates the coordinates of every component during runtime and decides what to focus. And we open sourced this library. So if you have similar issues with developing TV apps on the web platforms, you can check it out. I will post a link later. So that's the storybook. Let's just see how it works on practice on different platforms. So I will show a short demo of how to make this on. So this is the Apple TV emulator. So that's the native app running on the Apple TV. Then we also have the same. It was working just a few minutes ago on Android TV. Yeah, here it is. So this is Android TV native application. This is Apple TV native application. This is browser. And what we'll try to do is that we will try to use these components from UI Toolkit to build something like this, something like the home screen for the TV app. So first we can start by removing this boilerplate codes. So this is some kind of proof of concept application that has some pages already pre-built, but here we will start using the components from the UI Toolkit. So first of all, we can use the scroll view from React Native to render our rows of gallery items. We have some pre-made or mocked data because we don't have a real backend here. So we will use it from here. And then we want to map through our carousels. And for each carousel, we will take its title and its items. And for each of this carousel or gallery row, we want to use category component from UI Toolkit. Oops. So we will use the title of the category, we will use the items. Then we can say that one item component will be gallery item component that is also imported from UI Toolkit. So now when we have these items, we have our carousels. Each item will result in one gallery item. So we can see how it looks. Let's see if it works. Right, apparently it doesn't. How many of you have been to IBC in Amsterdam this year? Okay, not many. Because there we had the challenge to build this home screen in 100 seconds. So that was fun. All right, apparently I messed up something here. Yes. Okay, now we have gallery items. We don't have hero image yet. We only have rows of the items, which is already something. Let's see if it works on every platform. But while it's getting loaded, so the next thing we want to do is when we focus one item, we want to show this at the top of the screen as a hero item. So we will have the callback. So in order to define this callback, we can use React hook called use callback. And as you can see, this component is a pure functional component. It's not React component. So in order to persist the value of this function, so to not have this function to be recreated on every render, we can use this callback. So then the value of this function will be created only once. And then we can... So we need to store, when we focus an asset or gallery item, we need to store it in the state to know which item is focused now. So for this we will use another hook called useState, which will give us current asset and the method to set current asset. The initial value will be empty. So when the item gets focused, we will basically just call this method, set this item to this current asset value. And then to use this item, we will use another component from our UI toolkit called hero item. And we will use it here. So now every time when we focus an item, it will be stored in the top part of the application. Another thing here is in the browser environment, in order to focus something, it doesn't happen automatically, right? We need to do it. So from that library that I mentioned before, that we open sourced, React Special Navigation, we have the method called setFocus that every focusable component receives. And in order to set some kind of initial focus on your page, we can use another hook from React that's called useEffect, which will be executed only once if you pass the empty array of the dependencies. So how these effects work is that you pass the array of dependencies as a second argument to this method, and every time when any of these arguments change, it will rerun this effect. So if you want it to run only once when the component mounts, you can pass empty array. And then we just set focus to this whole page. And in this case, our application will figure out what to focus next. So it will propagate the focus to the first item, like this. Apparently, something doesn't work with our callback. Item focused. That should work. Okay, I'm not sure I want to debug this now. Or do I? Yes, of course. Okay, so on Apple TV, it looks a bit different, and Apple TV is smart enough to set the initial focus on any item if it's not focused initially anyway. And also, as you can see here, on the Apple TV, there is this parallax effect when you using this touch control. So this is how you can say that this is the native UI, because it uses native Apple TV widgets. And the same for Android TV. They don't have this parallax effect, but apparently, yeah. It's a development mode, so it's a bit slow. So now, let's say we want to play some video when we press the item. So we can do it by creating a callback on item press, which will be also a callback. We will use callback hook from React. We will take ID property, or in this case we don't even need this. And when this callback is getting invoked, we want to push a new road into our history. So we will go to player page. Let's see if that works. So we press this, goes to player, starts the playback in the browser. In the browser we are using Shaka Player. On Apple TV we are using native Apple player. So let's try something. Yes. So it works on Apple TV. And the same for Android TV. So when we press an asset, it doesn't work. Okay. And basically this is how we share the code between all the browser platforms, all the native platforms. We don't have any platform-specific logic here, and it works on every platform. And in our UI toolkit, every component is aware of which platform it's running on. So if you have some kind of specific use cases for some platform, you can handle this on component level as well. So I guess that's it for the demo. Apparently hero item didn't work. So you can check our special navigation package in the GitHub, and also follow our tech blog on Medium. Yes, thank you. Yeah, of course.